Hello, hello everybody. So we will be discussing about integers, which is the maths time for 7th standard. This is the first chapter in maths. So the first intention of this integers is we'll need to understand what is the objective of the lesson, what you need to learn in this, and what are the concepts that you should need to be aware of so that we can be able to understand integers. First of all, if you want to understand the objectives of this lesson, first is find the absolute value of an integer. So as and when you find out the absolute value of the integer is what the main understanding of this chapter is. The next one is apply properties and addition, properties of addition, subtraction, multiplication and division of integers. So the next step that you will be learning is how you will be able to apply the properties of addition, subtraction, multiplication and division in integers. The last one will be using a BDMAS rule for simplifying expressions. All right. So BDMAS is nothing but this one around, which I'll come back to it later. Yeah. So let us discuss this a bit later. Apply properties of integers in word problems. So these are the 4 things that you should be able to understand once you complete this chapter. Yeah. So the next one is moving on to the concepts. The first concept that you need to understand is first is what is natural numbers. So the numbers when you count from 1, 2, 3, 4 and all those till infinite. So till you complete the numbers, all are natural numbers. There is never a largest natural number. So that is your natural number. So generally natural numbers are represented by n. Yeah. And next is understanding what is whole numbers. Whole numbers are anything which starts with 0, 1, 2, 3, 4 and all those. That's a whole number. So the only difference between the natural and the whole numbers is where natural number starts with 1, 2, 3, 4, whereas the whole number starts with 0, 1, 2, 3, 4. Yeah. And the whole numbers gets represented by W. Moving further, let me discuss about what an integer is. Integer is nothing but a set of whole numbers and their opposite together form the set of integers. So it's quite simple, just need to understand integer is nothing but a set of whole numbers and their opposites together form set of integers. Yeah. So let the letter I or Z represents integers. So generally letter I or Z represents what an integer is. So if we need to understand here the set of integers, so this is something but a set of integers. So 0, 1, 2, 3, 4, 0, 1, 2, 3, minus 1, 2, 3, 4 is all a set of integers. Yeah. So let's understand this is a set of integers. Let's try to understand what is negative integers and positive integers. So anything with minus 1, 2, 3, 4 and towards the negative side of the numbers is your negative integers. Yeah. So here anything above 0 is a positive integer. So this is the difference between negative and positive integers. Yeah. Finding out the absolute value in an integer. So what we discussed was this is negative integers, this is positive integers. Now trying to find out an examples for how to find out an absolute integer. Yeah. So if at all you want to find out on the left hand side of the numbers, which is this, what is the integer here, it is, you will write it as minus 4. So the reason we have put it in brackets is just to make you understand that okay, whenever you write an integer you have something like an I beside it. Yeah, that should be a bit higher, so we put an I beside it is equal to 4. So the 4 is an integer here. Similarly for the positive integers 1, 2, 3, 4, so this is the 4, this is how you write as an integer, and what an integer represented is this. So how we represent an integer is like this. So minus 4 is equal to 4. This is how you will be representing an integer when you're talking about it. Similarly, another example will be minus 3. So you will need to take this, you represent it as minus 3 is equal to 3, which is nothing but same thing. And if you want to represent 1, 1 is equal to 1. And when you want to represent as an integer, how you want to read this two aspects of this and this, you will be reading it as minus 3 integer greater than 1 integer. Yeah. So this is about our concepts and this one about it. So moving to the better part of it, I will be trying to discuss about the properties of integers. Yeah. So let me go one by one. To discuss about the properties of integers, I will be trying to showcase you and try to talk about each property under each of this, so that it is quite easy for you to compare it and understand it. This is a table which you can try to sort out one by one and try to read out it, or if you want to read out it fully, you can compare it. So whenever you're reading one, try to hide the other one and read it and then complete it. Yeah. So first of all, closure property. A sum of two integers is an integer. This is about addition. So here I'm talking about addition, subtraction, multiplication and division. These are the four categories that we have, which I'll try to talk about, and these are the properties that I have. Yeah. First one, starting with the closure. A sum of two integers is an integer. So when I'm adding a plus b, the answer is going to be an integer. All right. Integers are closed under addition. This is what you need to understand. The next one is the difference of two integers is always an integer. A minus b is nothing but an integer. So we are telling that integers are closed under subtraction as well. Yeah. Next, product. Why do we tell as a product in multiplication is whenever you multiply with anything, that is a product. So when you multiply something out of another thing, that will give you a product. So product of two integers is always an integer as well. Here also integers are closed under multiplication. Moving on to the last one, how do you apply division in closure property? Yeah, if a and b are two integers, then a divided by b may not always be an integer. Yeah, that's the reason. So for this you can find some examples in your textbooks where they'll try to a is equal to 0 and b is equal to 1. So when you divide a divided by b, it will be 0 divided by 1, which will not give you an integer. That's the reason they have tried to put it across like this. Yeah. Moving on to commutative property. In this, the first section of addition will be sum of two integers remain the same even if the order in which they are added is changed. So no matter what you change the order of the addition, it will still be the same. The example here will be whenever you add, if a and b are integers, when you add a plus b is equal to certain number, b plus a also is equal to same thing. So that is why we are trying to tell that two integers remains the same even if the order in which they are added is changed. Moving on to third. So here addition is commutative for integers. So in case of subtraction, if the order of subtraction of integers is changed, the answer changes. Right? A minus b is never is equal to b minus a. So in this case, if you see here, so a and b are integers, a minus b will not be equal to b minus a. Yeah. So commutative property does not hold good for subtraction. Moving on to multiplication. In this case, product of two integers remains the same in which order they are multiplied. So it depends on what kind of an order you are trying to multiply. So in these cases, the integers a and b, no matter if you multiply a into b, will be the same as b into a. So multiplication is commutative for integers. Moving to the last part of commutative, which is if a and b are two integers, a divided by b does not equal to b divided by a. So when you divide minus 9 divided by minus 3 will give you 3. But whereas if you divide minus 3 divided by minus 9 will be giving you 1 by 3. Here, which means 9 divided by 3 does not equal to minus 3 divided by minus 9. Yeah, get that? So commutative property does not hold good for division integers. Moving on to our associative. Yeah, let me just freeze the pans. Yeah, so we have done with commutative and closure. Moving on to associative. In case of an associative, when you're talking about addition, sum of three integers remains same even if the order in which they are grouped is changed. So in this case, the example will be if a, b and c are integers, a plus b open a bracket, b plus c is equal to a plus b brackets plus c will still be the same. That is always be an integer. So addition is associative for integers. Moving on to subtraction. In this case, imagine if a, b and c are integers, so we got to use a minus a minus b minus c does not equal to a minus b minus c. Yeah, this is the reason. So associate property does not hold good for subtraction. Multiplication. Product of any three integers remains the same in whichever order they are grouped and multiplied. So when we multiply three different integers a, b and c, the answers will be the same for both of it. In this case, multiplication is associative for integers. Moving on to the last part, which is the division of integers, where a, b and c being integers, when brackets of a divided by b then divided by c does not equal to a divided by brackets of b divided by c. So example I've given here is 40 divided open brackets divided by 4 then divided by 2 minus 2 is equal to 5, whereas the single bracket minus 40 divided by 4 divided by 2 is equal to 20. So there is a bracket in between of b and c here, and in the first one it's a divided by b. So here associate property does not hold good with integers. Yeah. Moving on to identity. If 0 is an integer, the sum obtained is integer itself. The identity of integer does not change on addition of 0. So whenever we are doing addition into integers, no matter what, if I add a 0 to any of those, it will not change. It will still be an integer. So 0 is called an additive integer. Moving on to subtraction case. When 0 is subtracted from any integer, the difference obtained is integer itself. But when an integer is subtracted from 0, the result is not equal to an integer. So when what is trying to tell you is 0 is subtracted from an integer, the difference obtained will still be an integer. But when an integer is subtracted from 0, it will not be the same. This is the case. When a is an integer, a minus 0 is equal to a, but 0 minus a does not equal to a. Therefore, no identity element for subtraction of integers. Moving on to the third one. In case of multiplication, when an integer is multiplied by 1, the product of an integer product will be the same integer. Yeah. So in this case, if an integer is a, then a into 1 is equal to same as 1 into a, which is nothing but a will be your answer. One is multiplicative in the identity for integers. Yeah. Last one. If a is an integer, then a divided by 1 is nothing but is equal to 1. In this case, 7 divided by 1 is equal to 7, whereas minus 15 divided by 1 is equal to minus 15. So however, 1 divided by a does not equal to a, hence there is no identity element of division here. Yeah. Moving on to inverse property. So here inverse property is more like sum of integer and its additive inverse is 0, which is like inverse is nothing but the opposite of it. Yeah. So if an integer a, then a plus minus a is equal to 0. Here a and minus a are called additive integers of each other. So nothing but a minus a is an inverse property of it. So we don't have anything as an inverse property in subtraction. So moving on to multiplication. The product of an integer and its multiplicative inverse is 1. For example, if a non-zero integer, then 1 divided by a is called multiplicative inverse of a. Multiplicative inverse of 12 is 1 by 12. And 12 into 1 by 12 is nothing but is equal to 1. Similarly, 8 into 1 divided by minus 8 is equal to 1. So this is about a multiplication of integers. So we don't have any inverse properties in division area. So moving on to zero property. Zero property is applicable only for multiplication and division. The product of an integer when 0 with 0 is always a 0. If a is an integer, then when we multiply a into 0, still 0 into a is also is equal to be the same, but the answer would be 0. Yeah. So 2 into 0 is equal to 0, or 8 into 0 still be a 0. 0 divided by a non-zero integer is 0, whereas if a non-zero integer, then 0 divided by a is still a 0. Example, 0 divided by minus 2 is equal to 0, 0 divided by 4 is also equal to 0. Hence, anything divided by 0 will give you a 0, where a should never be a 0. 0 cannot be divided by a 0. So that's what they are trying to tell. A cannot be divided by 0. An integer divided by 0 is meaningless and hence not defined. So this is the best way we can try to memorize or understand our principles or properties of integers. So this is a table which can be helpful, which I will upload it into the YouTube channel. Please go through this and use it for your exams. Yeah, thank you so much. Thanks.